In this chapter, we will define elasticity, examine how it helps us understand economic issues, and look at the price elasticity of demand and supply. To illustrate, imagine you maintain social media accounts for businesses. If your costs rise and you increase your price, how will that affect your revenue and the number of accounts you keep? Elasticity measures responsiveness. Specifically, the price elasticity of demand measures how much the quantity demanded responds to a change in price, reflecting the price sensitivity of buyers. We calculate price elasticity of demand by dividing the percentage change in quantity by the percentage change in price. We typically report this as a positive absolute value. Using the standard percentage change formula can lead to different results depending on the direction of the price change, which is why we need a better method. By applying the midpoint method to our business scenario, we can accurately calculate the elasticity of demand for our services. Let's practice. Using the provided price and quantity data for iPhones, apply the midpoint method to find the percentage changes and calculate the price elasticity of demand. Next, we explore what determines the price elasticity of demand by looking at several real-world examples. First, consider Cheerios versus airfare. Demand for goods with many close substitutes is generally more elastic, as buyers can easily switch to alternatives. Second, compare Mountain Dew to all soda. Price elasticity is higher for narrowly defined goods, which have more substitutes, than for broadly defined categories. Third, consider insulin versus luxury watches. Price elasticity is higher for luxuries than for necessities, because necessities are difficult to forego. Finally, consider gasoline. Because it takes time for consumers to adjust habits, like buying more efficient cars, demand is more elastic in the long run than in the short run. To wrap up this segment, remember that demand is classified as elastic if elasticity is greater than 1, inelastic if less than 1, and unit elastic if equal to 1. Moving on to the variety of demand curves, we define demand as perfectly inelastic when the elasticity is 0, resulting in a vertical demand curve. Conversely, it is perfectly elastic when elasticity is infinite, appearing as a horizontal curve. In the case of perfectly inelastic demand, consumers show no price sensitivity at all. Quantity remains unchanged regardless of price fluctuations, as seen with goods like life-saving medicine. For inelastic demand, the demand curve is relatively steep. This indicates that consumers have relatively low price sensitivity, and the quantity demanded changes less than proportionally to a price change. Unit elastic demand is the intermediate case. Here, the percentage change in quantity demanded exactly equals the percentage change in price, resulting in an elasticity of 1. When demand is elastic, the curve is relatively flat. Consumers exhibit high price sensitivity, meaning the percentage change in quantity is greater than the percentage change in price. At the extreme, perfectly elastic demand occurs when even the slightest price change causes quantity demanded to drop to 0. This characterizes products with perfect substitutes. This table provides various real-world estimates of price elasticity. These figures show that elasticity varies significantly across different products. It is important to note that while a linear demand curve has a constant slope, its elasticity varies. It is more elastic at higher prices and less elastic at lower prices. Let's revisit our business scenario. If you raise your price, does your total revenue rise or fall? The answer depends on how your revenue change is affected by both the higher price and the lower quantity sold. When demand is elastic, a price increase reduces total revenue. This is because the decline in quantity sold outweighs the gain from charging a higher price. Conversely, when demand is inelastic, a price increase leads to higher total revenue. In this case, the gain from the higher price per unit more than offsets the loss from selling fewer units. In summary, if demand is inelastic, price and total revenue move together. If demand is elastic, they move in opposite directions. Let's apply these concepts. Consider pharmacies raising the price of insulin or a fare war causing luxury cruise prices to fall. How does this impact total expenditure or revenue? We can even analyze the impact of drug interdiction. By shifting the supply of illegal drugs, interdiction increases the price, which, given the inelastic demand for drugs, actually increases total spending. This analysis reveals that policies like drug interdiction may unintentionally increase total spending on drugs, potentially leading to higher rates of drug-related crime. Alternatively, consider drug education programs. By reducing the demand for illegal drugs, these policies shift the demand curve to the left, which can lead to lower prices and lower quantities, ultimately reducing drug-related crime. As we've seen, drug education reduces the demand for drugs. Consequently, both the price and the quantity sold fall, which leads to a decrease in total spending and drug-related crime. Moving on to income elasticity of demand. This measures how the quantity demanded of a good responds to changes in consumer income. Normal goods have a positive income elasticity, whereas inferior goods have a negative one. Cross-price elasticity of demand measures how the quantity demanded of one good responds to a price change in another. Positive values indicate substitutes, while negative values indicate complements. Now we turn to the price elasticity of supply, which measures how the quantity supplied of a good responds to a change in its price, indicating the price sensitivity of sellers. To calculate the price elasticity of supply, we again use the midpoint method to determine the percentage changes in quantity supplied and price. Let's walk through an example. If the price of pizza increases from $12 to $14 and the quantity produced in town rises from 150 to 170, we can use the midpoint method to find the elasticity. Economists classify supply curves by their elasticity. Supply is unit elastic when elasticity equals 1, elastic when it is greater than 1, and inelastic when it is less than 1. Supply can also be perfectly inelastic, with an elasticity of 0 and a vertical curve, or perfectly elastic, with infinite elasticity and a horizontal curve. Generally, a flatter supply curve indicates higher elasticity. Here we see a perfectly inelastic supply curve. Because the supply curve is vertical, sellers show no sensitivity to price changes, resulting in an elasticity of 0. When supply is inelastic, the curve is relatively steep. This signifies that sellers have relatively low price sensitivity, meaning the elasticity is less than 1. In the case of unit elastic supply, the supply curve has an intermediate slope, reflecting an intermediate level of seller sensitivity, where elasticity equals 1. With elastic supply, the curve is relatively flat. This reflects high price sensitivity among sellers, where the elasticity is greater than 1. Finally, perfectly elastic supply is represented by a horizontal line. This shows extreme price sensitivity, where elasticity is infinite. Ultimately, the price elasticity of supply depends on how easily sellers can adjust production. It is generally higher in the long run than in the short run, as firms have more time to expand capacity or enter the market.